gentlemen, Bruce McConnell here with Locomotive Systems Training. Welcome back. We're in air brakes. Remember, from the first video regarding air brakes, which is several back now, I teach it in the way you learn the ingredients to eat in a Big Mac. And then, of course, they are what? 12 beef patties, special sauce, lettuce, cheese, pickles on a sesame seed bun. And again, how did I learn that? Wasn't like I was really going out to really aggressively learn it. Just hearing a jingle, kind of like it's in the radio. You know what I'm saying? You hear a catchy tune, you kind of like it, then after a while you find yourself humming to it, then you're actually listening to the words, and after a while you're actually singing the song. Words, lyrics, the whole ball of wax. Well, we don't have any words. Well, we have words, but we don't have lyrics here. Maybe you can come up with a jingle. That'd be kind of cool. Anyway, so we're going to talk about locomotive air brakes again, pneumatic air brakes. And of course, it's air brakes, basic, which is pneumatic, which is, excuse me, a fancy word for air. Air brake systems continued, and this is LSTV-035. All right, so let's do a little review. Remember what I said, every time we, and again, if you really want to learn air brakes, you go back from the first one, you watch the first one, then in sequence you watch the second video, then you watch the third one. Then every time you come online and you watch it, you start with the very first one, then you watch the second one, there's that 2 all beef patties kicking in, and you'll be amazed in a very short amount of time how much you actually retain. Now, you will get to what we call a saturation point with air brakes. You'll get to a point you think you got it, you think you got it, you think you got it, and all of a sudden it just goes beep, 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 and you're like, I just lost the whole Marianne here, Bruce. I've lost it. Don't worry, because when I teach this class, the 5-day class, I tell you that after about Wednesday, you're going to walk out of that classroom door and you're going to say, I don't have anything. And I tell you, relax, you're doing fine. You just don't know how good you really are. You just don't know how much you've actually retained. And of course, I prove that as I go further and further along in the class. This will be taught the same way. So, for the review, what part is this? And I'm going to pause, give you a second to come up with the answer. This, ladies and gentlemen, is a 26C automatic brake valve. Now, you ever watch them old movies back in, I'm not even going to throw out the names of them, but there's different train movies out there where the engineers, he's moving this lever back and forth, and some of them are like really back and forth, and sparks are flying off at the wheels, and lights are flashing, and all kinds of things are going on. In real life, that's not really how it is. This is a 26C automatic brake valve. Now, the first thing we got to remember, with an automatic brake valve and a 26L air brake system, he controls the brakes on the locomotives and the cars. Okay? This guy is an air brake controller. This guy controls the entire braking operation of that entire freight train. As little as just a few locomotives and a few cars, or as many as however many locomotives you want to MU or multiple units together, put together, and also up like 150, 200 cars. So it's quite a remarkable tool when you think about it. Okay, so what is its function? Let's talk about that next. This valve initiates. Remember, there's 2 kinds of valves. There's initiating valves and there's responding valves. This valve initiates application and releases of both locomotive brakes and train brakes by controlling equalizing reservoir pressure, which results in controlling brake pipe pressure increases or decreases. Now, before I go any further, I want to stop and dissect this a little bit further. While you control equalizing reservoir pressure, that circuit is a whopping 26 feet in length on that locomotive. Every locomotive has an equalizing reservoir circuit, and they're all about 26 feet. For the pneumatic system, electronic air brakes, completely different circuit. Although it does the same thing, it does it in a completely different manner. It does it electronically and pneumatically. This guy is strictly all pneumatic or air. Okay, so this equalizing reservoir circuit is only 26 feet in length, but the brake pipe that it controls can go out for a mile, mile and a half, maybe even 2 miles out there in that train. So it's a little bitty controlling device, controlling a great big huge device. Okay, you can have that happen in hydraulics, you can have it happen in electronics or electrical equipment, but there's the case where the little guy is telling the big guy what to do. Okay, to kind of put that in a little bit of perspective. Another thing I want to throw out there to you is go back to the picture for just a second. What this is, if you grab that handle and you move that handle from left, which is, by the way, is the release and recharge position. And the reason I say release and recharge, number one, in its position all the way to its left, or your left, Release means that's the position, that's the only position of that brake system where the brakes are going to release, not on the locomotive but the cars as well. Release position. I also put in recharge because that's also the only handle position in which you're going to recharge the air brake system. If you're in minimum service or greater, you're not recharging anything. You have to go all the way back to release, and that's why I use the term release and recharge. Boom. Another term I want to put out there to you is this also is what I refer to as its ultimate goal is a brake pipe regulator. Now, what that means is, remember the little guy, equalizing reservoir, is controlling brake pipe, which is the big guy. Well, it's an equalizing reservoir regulator, which is regulating brake pipe. Our ultimate goal is to control the increases and decreases of brake pipe. So I always call this a brake pipe regulator. Okay? So that's what it does. A lot of information here just on this one valve. I'm tired already. Alright, so let's go ahead and go back a little bit. We've already talked about the function. Okay, what is this part? It's located directly below the automatic brake valve. This is called an SA26 independent brake valve. Now, if you remember from the last several classes, SA stands for straight air. What does that mean, straight air? Well, unlike the automatic brake, when you remove the automatic brake valve handle in the application zone, you don't get brakes instantly. You don't look over that brake cylinder gauge and the brakes just come right up. There's a little bit of a delay there. Well, straight air brakes is just opposite of that. That's air brakes right now. You move that handle, you get brakes just about right now. Boom, pretty quick. So if this is a tortoise and a hare, the automatic brake valve would be the tortoise, and the SA26 independent brake valve would be the hare. This guy's a lot faster than the automatic. But you got to remember, the automatic goes through all the locomotives as well as the cars and the train. This guy only sends a signal to the locomotives only. Okay? This guy operates, well, okay, let's talk about this first. I was going to tell you, before you put that up there, this guy creates two signals. He creates a pipe 20 signal, which is IAR, independent application and release. And he also has a 13 pipe, which is called actuation or ATC. Okay? So let's take a look at it. Once again, the function is, as the name implies, the brake valve provides independent control. Pipe 20, which I just said a moment ago, of the locomotive brakes only separate from the train brakes. Pipe 20 does not go out to all the boxcars. It stops at the end of that last locomotive. Okay, you can use it to augment brakes. You can use it as a parking brake, to which most railroads use. But they can also, like I said, use it for brake augmentation. Another function of this valve is to provide an air pressure signal, pipe 13 of the 26-valve quick release valve, to exhaust an automatic brake application. Interesting. So let me see. I'm driving this train down the track, and I take the automatic brake valve, and I move that into the application zone, and I apply the brakes. And then I'm required, or I will go down there to the independent brake valve handle, and I push the handle down and actually bail off the brakes I've just applied in the locomotives. Yeah, that's exactly what they do. Well, why would we want to do that? Well, I'm no engineer. I'll be the first one to admit that, but from what I've read and people that I've talked to, is that any time that you apply the automatic brakes with a train, you bail off the brakes, but the brakes on all the boxcars or all the cars stay applied. So you literally have the train slowing down or stopping the locomotive, not the other way around, or both stopping at the same time. Now, with that being said, I can also tell you, we'll talk about dynamic braking a little while later. Remember, there's three types of brakes on most modern freight brake locomotives. There's the automatic brake, there's the independent brake, and there's dynamic brakes. Okay? All right, so there is pipe 20 and pipe 16 from the SA26 independent brake valve. The next component, you tell me, that is what? That is the J relay valve. So it says so right here. The J relay valve, like I mentioned in the first several videos, it's a relay device. It's a responding device. It's a responding valve. Okay. Oh, look, there it is right there. It's a responding valve. That valve will sit there. Go back to the picture, please. That valve will sit there all day long and do absolutely nothing. Except there to twiddle its thumbs if it had any. It would just sit there all day long and do absolutely nothing until either the automatic brake valve or the SA26 independent brake valve told him to go to work. It's a very reliable valve. It's a very robust valve. Very dependable valve. Gets changed in the railroad industry way too often. And again, we'll talk a little bit about troubleshooting later, but it gets changed out way too often because people don't know how to test it. And it's real simple to test. All right, this valve will respond from either the pipe 16, which is the automatic brake circuit, or pipe 20, which is the independent brake circuit. Oh, look, here they are. It responds to an air signal from either the independent brake circuit, pipe 20, or the automatic brake circuit, pipe 16, that provides a large volume of air. You got to remember, these pipes that go from the automatic brake valve and the J relay valve, they're either 3/8, because I've been retired now going on 3 years. They're either 3/8 or 1/2 inch diameter. Well, even 3/8, or even if they were 1/2 inch pipes, if I had 8 brake cylinders, this big, or 9 inches in diameter, and that long, and I had 2, 4, 6, 8 of those, how long are these going to take me to fill those 8 brake cylinders up with either 45 pounds, or 55 to 62 pounds, or 72 to 75 pounds, depending on the brake application? It's going to take quite a while. But this valve right here says here a large volume of air. Let's go back to that picture for a second. Right here at the top of this valve, never take that cap off, is main reservoir. 130 to 140 psi, that's pounds per square inch of air, ready to go to work to send that air down to fill 8 brake cylinders. Now, if you look at my hands, if you look at an opening about that big as to an opening that's like, say, a 1/2 inch, there's no way that 1/2 inch is going to even remotely come close to filling up a volume that's about that big coming out of that automatic brake valve, or excuse me, coming out of the J relay valve, going to 8 brake cylinders. Believe you me, you're going to fill those 8 brake cylinders up fairly darn fast with an opening that big instead of an opening that big, or that's big. Cool? J relay valve, it relays that signal from the automatic or the independent, or both, down to the brake cylinders. Okay? In other words, this guy actually creates brake cylinder air. Okay? Okay, so now we're back at the 26C automatic brake valve. A lot of people think in the railroad industry and also out there in the general public that when I move this handle, air pressure comes here and goes right down to the brake cylinders. It does not. It doesn't. This valve sends a signal over to a control valve that creates a signal that goes down to the J relay valve. That purple air, that's pipe 16 air, I know I'm talking circuits, but you're going to have to bear with me for right now. It'll make sense a little bit later. This guy does not send a signal that sends air to the brake cylinders from itself. Air does not go down out of this valve and right over the brake cylinders. Doesn't do it. Not enough volume in there for it to do it. Now if we go ahead and go back to the J relay valve, and I don't even know what slide number that is. Alright, so this is the guy that receives the signal from the automatic brake valve or the independent brake valve. This is the guy that sends the air down to the brake cylinders. He's got that large capacity of air from the main reservoir in a rather large opening as opposed to an opening that diameter of my finger. Okay? Alright, so we're starting to make little heads and tails of this. Again, the J relay valve, remember it's a responding valve. It responds to pipe 20 or pipe 16, or both. Large volume of air from the J relay valve sends that air down to the brake cylinders. Now, how many different types of J relay valves are there out there? Well, there's 3. Actually, there's a lot more than 3, but there's 3 different types. There are a non-multiplying valve. Well, let's see. A non-multiplying valve would be, let's say I had an input pressure of 45 pounds to the input side of that J relay valve. If it spits out 45 pounds at the other output down to the brake cylinders, that is non-multiplying. The signal came in as 45, the brake cylinder pressure that went out was 45. The signal and the pressure were non-multiplying. Same in, same out. Multiplying up, J1 414, J1 616, J1 818, or J200. Those are all multiplying air signals, and I'll explain that. On a J1 414, that's a multiplying up. I put 45 pounds into the J relay valve, and not 1 input pressure. I put it in at 2, port EX and port 16. I know it doesn't make sense now, and don't worry about it. Don't even get your head wrapped around it. I'm just throwing this out there just to try and get it kind of like a pre-soak of, if you will, of knowledge. Okay? J1 414, 1 pound in, 1.4 pounds out. I'm going to get about 61 pounds of brake cylinder from a 45 pound double input. That's a multiplying up signal because it was greater than the initial 45 that went in. J1 616, 45 in, 72 out. J1 818, excuse me, J1 818, 1 pound in, 1.8 pounds out. I believe that's about 81 pounds, and I'm just guesstimating here. J200, 45 pounds in, I double that times 2. I'm going to get 90 pounds out. But what I'm after here is that every one of these types of J relay valves is multiplying signal up. It's going to be something greater than the input signal. That's on the independent circuit. Oh yeah, I had to throw that in there. Great. On the automatic circuit, they're all just about, most of them are just going to about read whatever pound in, on the 100% diaphragm, whatever they put in, they're going to get out. Next one, multiplying down circuit. I'm going to put, say I put 45 pounds of independent pressure in, I'm going to get something obviously less than what? 45 pounds out. That would be a multiplying down. J1616, or J16B, J46B, J64B. See, that wouldn't be confusing with that. J84B, J84M. So there's a lot of different types, as you can see here, with a lot of different outputs, input versus output pressures. Also different pressures versus independent application versus automatic application versus emergency applications. So they're all different. That's why whenever you get on a locomotive and you're going to do an air brake test, first thing you got to do is drop that air door down carefully, safely, following all your company rules and regulations. You got to know what kind of J relay valve you're going to have, so when you apply the independent brake and the automatic brake, you know what kind of expected output pressure that J relay valve should be giving you. Okay? You don't just hop up in the cab and whee, start moving handles. What if you got a problem in that circuit and your automatic or independent or 2016 double check valve or your J relay valve isn't working right? That's why you have to know which one you're going to be working on before you start the test. Whew, a lot of stuff here. And this is what? Well, let's see, it has 3 components. One's called the pipe bracket. One is called a 26F service portion. And the other one is called a 26F quick release valve. And what is this component? Has three pieces to it. A pipe bracket, a service portion, and a quick release valve. Ladies and gentlemen, this is known as the 26C control valve. The name control would tell me that that's going to control an action within the confines of that locomotive and train. Maybe it's used in the automatic circuit. Let's take a look. Its function is, valve used in the, oh, there it is, the automatic brake circuit consists of 3 components, a pipe bracket, 26F service portion, and a 26F quick release valve. Okay, here we go. Oh, what component is this? Well, remember the last class, and what this is, first of all, let me see what the name is. It's a branch pipe filter. Oh, boom, popped into place. Branch pipe. Remember what I said in the last class? I said, if you're sitting there watching, I take a piece of paper and write the word B, and then right below it, put a great big P. Then I want the equal signs below the P, and then I want you to put a B above that, or below that, and then a P above that. So it should say BP equals BP. I always do this in every class. And I want you to know, what you're going to learn now is that in the branch pipe, there's brake pipe air, orange air. And this pipe right here, it's a 1-inch diameter pipe, a pretty good sized chunk of pipe. It's going to come through with a open and close valve here, otherwise known as a branch pipe cutout cock. And it's going to go in through this, it goes a branch pipe filter. Now, here's the deal. There are 11 chokes and orifices in that control valve. If you go back one real quick, go back one right here. Between this pipe bracket and this valve, there are 11. I did that right? 5, 10, 11. There are 11 chokes and orifices that require absolutely clean air to operate in, otherwise they will malfunction. All right, let's go on. Okay, so this filter, this little branch pipe filter, ladies and gentlemen, is designed to provide additional filtration inside this branch pipe going up to that control valve to ensure we have clean air. You start plugging up those chokes and orifices, that valve is not going to work right. Move on to the next one. Okay, go ahead. Again, there it is, identical filtration of the brake pipe air before it enters a 26F control valve. Here we go. The last one from the last class. Okay, this is a combined strainer and cutout cock. Let's open it up. Branch pipe cutout cock. Okay, this over here is the branch, what they call a branch. Branch of a tree, right? This tree is part of the whole tree, but the branch right here is a branch of that tree. Or this is a branch of the brake pipe system. They put that cutoff valve here so they can cut that valve off if I'm out in the main line on a freight train, I'm going to cut this valve off and only drain that little bit of air from here up to the control valve instead of draining air that I would either go down and close the angle cocks on. That way I'm not having to worry about recharge times very much. You notice I said recharge times very much. It's important to understand that. Branch pipe cutout cock. You move with the horizontal position, you throw the line up, the ball valve in there, that valve closes, and that brake pipe in that branch pipe from here backwards stays at whatever handle position is. Usually in releases at 90 pounds. This allows me to perform maintenance either on this filter or the control valve or the quick release valve, whatever, without depleting the brake pipe in that system of that locomotive. Okay, let's go on to the next one. And there it is. Used to isolate the F27 control valve from the rest of the brake pipe system when servicing or maintenance are required. Boom, let's go to the next one. All right, so to continue on, now we're going to look at a couple new components that we haven't talked about yet. This is called an A19 flow adapter. Okay, let's take a look at it. This component has a 1964 orifice or choke that restricts the amount of main reservoir air pipe 30 air that can flow to the brake pipe system. In other words, there's a relay valve inside the 2060 automatic brake valve. The relay valve creates a brake pipe air. Okay, what they do is they reduce the amount of volume that goes from the main reservoir, which is a 1-inch diameter pipe, and they reduce it down so it controls the amount of output of the brake pipe air going out to the train, that locomotive's end train. That's what that valve does. Okay. Dead engine cutout cock. When you cut in the unit's DIT, opening this valve will allow brake pipe air to enter into the number 2 main reservoir and charge the main reservoir up to what the pressure regulator is set at, usually 31 to 40 psi. And let me explain to you what a dead engine cutout cock or a dead engine feature is. Let's say I have a locomotive where the engine blew up, boom, or the main generator blew up, boom, or the air compressor blew up, boom, and it's shaft driven. Something that caused or we cannot rotate that main generator and engine. They call the prime mover. So what they'll do, they'll take that locomotive, they'll open that little valve, and they'll put it dead in train, and that way it'll act like a loaded boxcar. Okay? And what we do is we reduce that pressure down, usually to 31 to 40 of main reservoir, so we can get the proper braking application of that dead locomotive to operate like a loaded boxcar. Otherwise, if its pressure was too high in main reservoir, you run the risk of locking up the wheels, and that's a bad thing. You don't want to do that. Okay, let's go to the next one. Whoop. Looks like we're at the end of our session for today. But what a review. I mean, look how we've expanded just in the automatic brake valve and the SA26 independent brake valve and the J relay valve. We now know that when you remove the automatic brake valve panel, you don't send air signals from there right straight to the brake cylinders. Has to go through a couple of valves to get to there. Same thing with the independent as well. So, hopefully you're liking what you're seeing here. I encourage you to go over to our website. And again, I want to point out to you, because we've had some difficulties. This is our website, www. That is not a number. That is a letter, lowercase l. As in locomotive, as in system, as in training. So it's www.lst-ca.com. Once again, www.lst-ca.com. Take a look at it, give us a call, send us an email, and we'll go from there. Thanks very much for watching, and have a great day.